A parallel circuit contains branches and junctions, and breaking one branch will have no effect on the other branches. They are independent of each other. Current in a parallel circuit, the supply current is equal to the sum of the current in the branches. Supply current is equal to I1, I2, and I3. We can see that the current flows from the supply and can either go straight down or along this branch. Then it can go down or along this branch and down or along this branch. The current is shared between the branches equally, depending on the resistance of the components in that branch. In a parallel circuit, the voltage is the same at all branches. Vs equals V1 equals V2 equals V3. All of these branches have the same voltage as the supply. As mentioned in the previous video, an ammeter is connected in series, so the ammeter is connected straight across with the component that it is measuring. But a voltmeter, which measures the voltage, is connected across the component in parallel, with one wire on either side to measure the potential difference between the points. Resistance in a series circuit uses a slightly more complex formula. 1 over R total is equal to 1 over R1, add 1 over R2, add 1 over R3, or however many components there happen to be in that circuit. Here, the components are connected in parallel with 3 different branches. Adding more components will decrease the total resistance, increasing the current, having the opposite effect that it has in a series circuit. The total resistance is always smaller than the smallest resistor in a parallel circuit due to this formula. A useful tip to quickly find the total resistance of 2 parallel identical resistors is to just half one of them. If you have 2 4 ohm resistors in parallel, you can just half it to get 2, and that is the total resistance of these resistors.